Gravity sounds mysterious, but I promise it's simple enough to feel in your bones. Literally. Let me start with the story we all know. Everything with mass pulls on everything else. That pull is gravity. The bigger the mass, the stronger the pull. And the farther apart things are, the weaker it gets, following the inverse square rule. Imagine two clay spheres on a table. If one doubles in mass, the pull doubles. Move them twice as far apart, and the pull becomes 1/4. That's Newton's law in action. Now weight versus mass. Mass is how much stuff you're made of. Weight is how hard gravity pulls on that mass. On the moon, same mass, less weight. Because the moon pulls less. So why do things fall? Near Earth, gravity accelerates everything downward at about 9.8 meters per second squared. Drop a clay ball and a clay feather in a vacuum, and they land together. Air is the only reason a feather seems slower. Orbits are just falling with style. Fire a spacecraft sideways fast enough, and as it falls, Earth curves away beneath it. It keeps missing the ground, so it keeps falling around the planet. Tides? The moon pulls a bit harder on the side of Earth closest to it, and a bit less on the far side. Water responds, making two bulges, high tides, chasing the moon. Here's where Einstein adds depth. Mass and energy don't just pull, they bend space-time. Picture a stretchy sheet. Put a heavy clay planet on it, and the sheet curves. A rolling clay marble follows that curve. To us, that path is gravity. This also bends light and slows time, just a little. Your phone's GPS corrects for that, or you'd be off by meters. Zero gravity in space? Not really. At the space station, gravity is still about 90% of Earth's surface strength. Astronauts float because they're in continuous free fall, orbiting Earth. The fall balances the pull. Try a tiny experiment. Drop two different shapes indoors. They hit together. Gravity treats mass equally. Now swing a clay pendulum. Its period mostly depends on length, not mass.